Okay, guys, good afternoon and welcome to today's live coding session. And as we stated yesterday, today we'll be taking GitHub actions and for spotting errors early. So this is just taking something that is related to, and you never even start. Okay, guys, welcome to today's live coding session. And my name is Olabi Adenu as usual. And today we'll be taking GitHub actions for spotting errors early. So I'm just going to be taking today's LCS as an addendum to what was done in stage B, and for you to get a very basic, I think, understanding of what your follow-up labs entailed. So if there was any misunderstanding on the steps or anything that you had when you were completing your follow-up lab, with this live coding session, I feel we'll be able to resolve everything and you'll be able to have a step-by-step you have to have a step-by-step knowledge and gain more understanding of what GitHub actions are. So this is the this is the Visual Studio Code we'll be using, and we'll also be using GitHub because that's where we can get access to the GitHub actions. So I'll be creating a new GitHub page for this. So I'm just going to change my screen to my Chrome browser here. So with this, because this is the best. Okay, let me just go to GitHub. I have the tab here already. I can just switch here. So if you have any question or anything that you want to ask or anything, you can just drop it on the chat and I'll pick it up and we'll talk about it. That's relating to both this live coding session and the follow-up lab that you created, that you submitted recently. So I'll be creating a new repository for this, and I'm going to call the repository. I'm going to call the repository calculator action. I'll call it calculation action repository. So it's available. It's going to be a public repo. I'm going to skip all of this and then I'm going to create the new repository. So if you remember correctly, when the path for action files in the path for action files in the repository is .github/workflow/ the name of the action file basically. So this is the new repo, and for easy stuff, I'm going to just I'm using HTTPS and I'm going to clone this in our I'm going to clone this into our so let me switch to our Visual Studio Code, and then I want to clone a Git repository. So I can just have used this option here, but I'm used to using the terminal, so I'll just create a terminal and then I'm just going to clone it using the git command line. So that's git clone, and then I'll paste the link. So one of the ways for you to clone, there are many numerous ways for you to clone GitHub repositories. You can use the GitHub desktop, which is a GUI version of Git, basically. It is provided by GitHub. That's GitHub desktop. If you are someone that is very familiar with command line tool, which is the best thing that a programmer has to know how to use. With command line tool, you can clone any GitHub. GitHub is not the only Git platform we have online. There's GitLab, there are Git books, and there are also Git-based workspaces that are also online, but GitHub just happens to be the most popular. So with GitHub desktop, you can only clone GitHub repositories. But when you are familiar with Git, because Git is the building block for all of these Git-based platforms. So when you are good with Git, then you can use Git clone to clone what any, be it GitLab, be it GitHub, or any other one. You just use the Git clone and you paste what the link to that particular repository, and then we're able to be click and clone into it. If this is your first time, it will ask you for you to log into the platform, blah blah blah. Those are just credentials, and that's that. So I've cloned into an empty repository. Yes, I get. So as you can see now, I have a folder called calculator action, which is the name of the repository that we just created. So I'm going to change into this repository, cd calculator action. So that's on that. So now I'm in this calculator action. This is just me, just like saying, okay, I'm going to open a folder that is called calculator action. So to make it very simple and to showcase the power of action, I'm going to use a very, very simple Python calculator app here. So the Python calculator app that we're going to do is just a basic one. You get. So I'll also be using in this live coding session a framework called PyTest. So for the programmers out there, Python programmers, or in programming, basically there are testing frameworks that are used to fact check the result of programs. What they do is that they make sure that the response that is being gotten is the expected response. So these testing frameworks are there to make sure that if you accidentally made a mistake in your code, you get, when you use these testing frameworks, it helps you to spot it, in the sense that, so let's say with what you had in mind, that you write a piece of code to multiply two numbers, for example. So when writing your code, you made an error, but you did not spot the error, but it is not like an error that will break the code. The code is still running. So with your testing framework, you can write a test to ensure that when you multiply two numbers, the result you get should be, let's say you want to multiply 2 and 3, your result should be 6. So you write a testing framework that calls that multiply function, that multiply code, and then runs it on 2 and 3, and then sees if the result is 6. So if the result is not 6, then you know that there's an error in the code that you have to fix. But if your result is 6, then you know that your code is correct. So we'll be integrating that PyTest. So the testing framework for Python, the more popular one is PyTest. There are other ones that I use also, but the most popular one, which is also the Python standard, is called PyTest. And for other programming languages also, they also have their own specified and go-to testing framework. So that's that on that. To start all of this, let me just create the calculator app basically. So I'll create a file called main.py. Because you guys are on a mini break, so that's, you can see now this file is not here, so I have to move it into this folder basically. Yes, moving. So because you guys are on break and I don't want us to take too much time, I won't be going into I'm going into much of creating a big stuff. I know I'll just create something basic. So I'll call it I'll just say def add add function. Okay, so our add function will take what? X and Y. So it's a very, very basic calculator. And what it does is that it returns the what? It returns X plus Y. I'm going to do a subtract function. That takes in X comma Y also. It returns what? X minus Y. I'm going to do a def divide multiply function. That takes in X and Y. And it returns what? It returns X times Y. And I'm going to do a def divide function. That takes in X comma Y, and it returns a what? X divided by Y. So these are all of the functions that our calculator is going to be implementing. So just to just showcase like a user-friendly stuff, I'll just say, okay, print Welcome. All these are not needed actually, just to see the difference in methodology of how stuff are run. Oh, what am I saying? There's nothing like returns. Okay. So this should be the return key. So welcome calculator. Okay, then after that, we're going to tell the person to select. So let me use this for this. 1, 2, 3. Select option. So if the person wants to, number 1, addition. We have number 2 to be what? Subtraction. We have number 3 to be division. Sorry, multiplication. You can order it anywhere actually, but just me. It's not something that is important. I just want to see. I want you guys to see it working like in a user-friendly way. And then seeing how we just use PyTest to just test list of the function that we want. So 4 is what? Division. So number only. So we want it that to make it easier. So therefore, choice is equals to input selection. Okay. So if choice, so after the person inputs the selection, then we need to get what our values of x and y. So I'll say num1 equals to integer, or let me just say floats, because we can want decimal. Floats inputs number 1. Anyway, 2 equals to floats inputs number. So this, let me just put 1 and 2 just for semantics to know that they are 2 different numbers. And then okay, there's no space here. Now that they're not symmetric. So and then I just say if choice is equals to 1. So there are many basic ways that one could have done it. I just want us to do something that is very fast and then move on to the nitty-gritties. But for guys that have not been like into coding a lot previously, but I feel everyone in the DevOps track are guys that like at least have the knowledge of coding or something, or Python, because their money internship does not teach Python from the back or from the ground up. So I think you guys should have a feel of what it is I'm doing, and this should just be a basic implementation actually. So if check is equals to 1, just call the add function and num1 and num2. Elif so we call the what subtract function and num1 2. Elif choice is equals to 3. We call the what multiply function num1 and num2 else. So this can just be the last one. We call the what divide function 1 and 2. So with this, I think we are good to go. So I'll just run the code here. Python main.py. So you can see welcome calculator, select option. So if I select the option to add, I want to add 20 to 55.78. So I'll have, oh, sorry, I forgot to print the results. So let me just add print lines here. So this is the print line here. The print line here. And another print line here. Okay, so with this now, when I do this, I say I want one, and I want to add 20 to 55.78. I have what, 75.78. So basically, our calculator is working sort of like the basic implementation of the calculator. So that's the first thing. So I'll come here. So to add it to the Git repository, I'll come to Git add all files. So this is me using command line. I could have just easily come here to do this, but this is faster and better. So git commit. I want the message to be main file. So git push. So with this now, what I've just done here in this 3 line of code is to make this change. Tested an error. What's happening? Let me check here. Let me just check the code. But what I just did there is that I specified that in the repository that we cloned, I wanted to push this file into that repository. So let me come here and refresh this page to see if our file has been added. Okay, our file has not been added. So let me come back here and see what is happening. Let me just change something here. In this world, it's just us. Changes. So your commit message can be anything, but I just want to commit this. So it has been successfully committed, then I should be able to push. I don't have permissions to push. Why? Did I make it public or private? I'm coming. Let me come here. Settings. Let me check. I don't know why it's. Let me try this method. Okay, yeah, the screen is not frozen. I'm just trying to see why I cannot push. Let me just switch. I'll switch to my Visual Studio Code now. So you can see that I'm having an issue pushing to the Git repository that I just created. So I don't know why that is, but that's something that might create, I don't know, it will take some time trying to fix it while I'm on call. So I will just go through the normal process of uploading with what? With drag and drop. So the issue must have come up when I was creating the repository. Either the repository has not been fully initialized before I closed it, or the repository has or the repository is not public, it is private. But I'll just create a new file here. Okay, no, not, I don't want to create a new file. I want to upload a new file. Yeah, that's the better one. Okay, so I want to upload a file. So I'll come here and pick the main.py file. Oh, I see. So I'm going through the normal way of adding files to GitHub. So you can see now that I've clicked the option to upload the file and I've selected my main.py file. So I'm just going to commit this file first. So okay, so but the reason why it is not cloning, I don't know why. But okay, so let me switch back to my Visual Studio Code. So based on that, if I do a git pull, refusing to merge unrelated history. So I don't know why there's an issue with something. Okay, let me do something. Let me do this. I'm going to delete this here. Let me close this, delete this. Yeah, so I've deleted that now, and I'm going to try to clone. Let me just check. I think I know the issue. If I check my git here, so okay, so I'll just come here and try to clone one again. So I'll provide the repository URL. I'm just going to pick this up from my Chrome page. This is the repository URL. So I want to clone one. Clone a Git repository. That's that on that. So I'm going to clone this. I'm going to clone it into this folder that I am currently in. Okay, so I'm cloning the repository already. Let me add it to my current workspace. So therefore, if I do a git, so if I change now, okay. So you can see now that this has both the main.py file, but I won't want us to waste much of our time debugging that, but that's the first thing I want us to see there. So you can see now that if I open the main.py file on the Chrome page, so you can see that this is our code that we have written and it's now on our our GitHub repo. So the next thing I'm going to be doing now is I'm going to be creating the PyTest file. So let me just go back here, and then in this workspace, let me just cd . So I'm in here already. So I'll just go back here, cd . Yes. Calculator action. Okay, so that's been the PY file. So I'm going to create a new file called tests.py. So this is me trying to use the PyTest framework. For you to use the PyTest framework, it has to have been installed on your system previously. For you to use the PyTest framework, it has to have been installed on your system previously, and you can confirm that by just doing. If you want to install it, you just do a pip install PyTest. You get, but since I have PyTest on my system already, if I just run a PyTest here, it is not recognized. Okay, let me confirm that my PyTest is installed. PyTest. So as you can see, even I did not know that my PyTest was not installed, but I think it's just for this workspace. So PyTest is being installed already. And once PyTest is installed, then you can just call the argument called PyTest. And the way PyTest works is that once you call it in any folder, it goes through each folder and subfolders in that directory to look for anything, any folder called test.py, or any folder that has test added to his name. So it automatically recognizes that this should be a test folder. Should be a test file, and then it runs the tests that are in that file. So if I run PyTest now, I should not get an error anymore. I should have something trying to run, but maybe there will be no test found or something. You can see. So this is no test run. Why? Because I have not created a test that has to be that needs to be run. So I'll come here and now start writing the test function. So the first test function I'll test add function. Okay, so that's the first test function. So there's a methodology to writing PyTest file, in the sense that when you want to do it, it's not really standard, but it is advised by GitHub as a very good way to do it, as it allows you to be able to identify what each test is doing, and for you to easily identify where the error is coming from. I don't know if you get what I'm trying to say. So when you have something like that, it allows you know that, okay, this is the place where I'm meant to get this issue. This is the test that this issue is coming from, basically. So I'm going to call of this now. So I'm going to call test add. I'm coming to do this. Okay, so as I said, I'm going to for this to work. So this is the test add function. And then for me to be able to use all of those my functions that I created, I'm going to be importing them. So from main, I'm going to import what? I'm going to import add function. I import the what subtract function. I import the multiply function, and I also import the what divide function. So test add function. So there's a keyword called assert. So I'm going to assert that if I call the add function on 2 and 3, I'm meant to get what 5, because I know what the add function does. What it does addition. So if I'm going to call the test subtract function, so I know now that since it's a subtract function, I'm going to assert that if I call the subtract function on, let's say, 25 and 5, I should be having my answer as what 20. So I'm also going to test the multiply function. So I'm testing all the functions basically. Multiply function. And I know that if I do what, I'm going to assert that if I call the multiply on 4 and 5, I should also have my answer as what 20. And last but not least, when I call the def test divide function, and if I call, I'm going to assert that if I divide 2 according what the divide function on what 2 and 1, I should have my answer as what 2. So this should be it on the PyTest. So if I come here now and write PyTest, can you guys hear me and help me confirm if you can see my screen? So I think I just had the very sharp glitch in connection. So but I think I should be back now. So if you can hear me or you can see my screen, just drop a chat for me to continue. All right, thank you, teams. So as I was saying, so you can see reading from consider blah, 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 OSI or PyTest, reading from standard inputs. So that's the stuff. So this is an issue now because what this is trying to do is that there's the way Python works is the way Python works is that when you create a file and you import it, you can see that I'm doing a from main import. So it is trying to import everything that's been written in that file. So I just wanted to show this as an error. So this is one of the things that PyTest also does. Imagine if we had not done a local testing, for example, and if I had integrated PyTest into my GitHub, I would have also gotten this error. But as a developer, before you even try to move from your local workspace to a remote workspace, you should be sure that locally your code is running, basically. So me using PyTest, I can see that there's an issue here. So how do we solve this issue? I'll go back to my main.py file, and I'm going to try to tell Python that anything that is run apart from here. So there's this Python stuff called if should this be, I think it should be name exactly is equals to underscore main. Then that's when you should do this. So what I've just done here is that I've told Python that I know this is a file that can be imported into another place. Like this is a file that can act as a module where I can import it. So I don't want every line, the file that we have created for good user interface, I don't want it to run if it is being imported. I know that when it is being imported, I want what? I want something that is what? That is going to be I want something that is going to be what? That is just going to give me access to all of these functions. So Control Z. So that's what I've just done here. So you can see now that if I come here, just to showcase it, if I still run Python main.py, you see my code still works as usual. I want to add 2 to 3. I have 5.0. You get okay, this will also be an issue, but we'll solve all of this. So if I want to add 2 to 3, so I know this is this. So this still works as usual, but when I come here now and run PyTest, that error the error we had, we should still have an error, I think, because of type conversion and type difference. But the error we had previously that was due to all of this code running should not come up now. So you can see now our test has passed. So now when we come to our test main.py, you can see now that all of our tests now, because I've added that line of code, when I import main, all of those other codes are not what's running. It's only the functions that we need that we imported. So that is what that key. It is a popular key in Python. Another way to work around it is to define all of this inside the function. If the function, you call that function main function, and then you call the main function basically. So that is that on that. So now we can see that our test has passed, means that what our code is running the way it should run. So based on that, I also let me try to see if with the new way I have cloned it, if I can push, hopefully. So I'm going to come here, source control. I'm going to unstage this test main.py. So I'm going to unstage this. So I'm just going to stage this, and I'm going to stage this also. So these are my stage changes. I'm going to call them commits. I'm going to commit them. And let me see if I can push. So the last time when I tried pushing, I had an error. You see, you can see that there's this error. So this error is coming as an issue of something in the repository, but I won't let us focus on that. So I'll just change my screen back to my Chrome page here, and so let me come back to my Chrome page here. So this is the new repository that I just created, and based on this, so this is it. So I'm going to add new files again via upload. So I'm going to just add files. I'm uploading files, and I'll just choose my files. I'll just drag and drop here basically. So I'll come here into my calculator action. I'll click on this and this. So these are the 2 new files that I created, main.py and test main.py. So this main.py should override the previous one, and then I'll commit the changes. So the reason why, another reason why I'm feeling I'm not able to use the command line is because of my credentials. I actually have a work GitHub account and a personal GitHub account on the system. A personal GitHub account on the system that I'm using. So I think the credentials conflicts can also cause an issue. But just to confirm what we have, so I'm going to open up our main.py, and you can see our main.py has also been edited, and I'm going to open our test main.py. So now our test is working. So the last thing we're going to be doing now is we're going to be creating the action. So creating this action now, and with that we should be good to go. This 1241, I want to set up the workflow myself. Okay, so if I'm going to set up the workflow myself, so this is our main.yaml. So this is our YAML file where we're going to be setting up our workflow. So if you follow the course contents, there are standard keys, just like the way Python has its own normal keys. There are standard keys that you can use in an action file to determine what it is and what it is that you want to do. So basically for the action file, just to not waste our time because we spent 41 minutes already, I'll just pick up the template that I had created already. So I'll just paste that here. So I'll just go through each of them one by one and then explain what they do to you. So the name of your action file is going to be what? PyTest. That's number one. And on is a keyword. These are things that I don't think I have to explain anymore because they have been explained during the course contents, if you flow with me. But what on does is that this tells us when we want the workflow to run. So this is when we want what? This workflow, when is it going to run? So we have specified that this workflow should dispatch when there is a pull request. And what type of pull request to make it run? When the pull request is opened or when the pull request is what? Reopened. So permissions, it has the permissions to read content. If it's a workflow that is going to change things, then it should also have the permission to write. So this is just a job. It's just like a list of functions and what we are going to do. So the first job, our job is running on Ubuntu. So there has to be like, for example, on my system, I'm running Windows OS. It's the Windows OS that I'm using to what? Run all of my operations. So your GitHub Actions also has to have a platform, the runner that runs what? That is used as a platform to run all of your what? All of your tests and your job. So it is running on Ubuntu latest. And the first thing we do is we check out the code. So checking out of code allows us to be able to run our action in like a what? In a remote space sort of. It's just like, okay, you're moving from your local repository into a remote origin where all of your files are still there. So after you're done running your test and if it works, then you come back and check back into your local repository. So I'm setting up Python actions. So what this does is that this is like me saying that I want to install Python on my on my Ubuntu system. That is the layman representation. So if I set up Python, it means that what I'm selecting Python 3.10 version. I'm installing it into this Ubuntu runner that is going to be used to what? To run this action. And the only library I need. So this is for when you are doing something bigger. This is for when you are doing something bigger. So you might need your code base might work on some libraries. So this is where you would install those libraries. So I'm just going to install what? The PyTest library because it does not come standard. It does not come with a list of installed modules alongside Python. So this is me installing PyTest, and then I'm just going to what? Run PyTest. So this one is like saying that I want a command line on this Ubuntu. And after giving me the command line, just as I have on my terminal in Visual Studio Code, I then just want what? PyTest. I don't know if you get what I'm trying to say. So this is it. I'm just going to commit my changes here. Create main.yaml. Yeah, commit my changes into the main branch. So now that is done. So if I just go into this calculator action file, so all of this is there, you can see. So if you remember very well, what did we say? We said for this workflow to dispatch, we need a what? A pull request that is open or a pull request that is what? A pull request that is what? Reopened. So I'm going to showcase both of that, and with that we are done. So for the pull request that is going to be open, our what? Our PyTest will run successfully. Meanwhile, for the pull request that will be reopened, our PyTest will run, it will not run what successfully. So to do that, and how do we create a pull request? I think this is also something that we should have treated. If it was not treated in stage B, then it will be treated very well in stage C. So I'm going to be creating a new branch. So I'll call it I wanted a new branch. So this is a new branch. I'll call it testing branch. Testing branch. So I've created the branch. So once I click on the testing branch, so that's that on that. I'll come back into calculator action, and then I'm going to switch from, I hope this is the screen I'm sharing. Okay, yes. All right, so I'm sharing the correct screen. So I'm going to switch into my testing branch. As you can see, I've switched into my testing branch. So what branch does is that it's a way for you to work to make changes to your code, but not affecting the main code base, basically. So when you are done making the changes to your code and you are sure that your changes are working as it should, then you can adopt those changes into your what? Your main and actual code base. So that's a way of it, like saying, okay, you create a copy of a folder, make changes to those folders, make sure that those folders are working as they should, and then you copy the changes from the copied folder to the what? Main folder. So in this one, I said for our open branch, our stuff, for our open branch, our PyTest is going to run successfully. So I'm going to come into main.py and I'm going to edit main.py. But the edit I will make is not an edit that will change. So you know that we are working with the assumption that people will work on different code bases, many people working together. So let's say your own was that you created this code base. It is the job of another person to come and link and to comment. So I'm going to edit this file and I'm going to be adding comments to each of them. Okay, addition code. And that person comes here to do what? Subtraction code. We have another comment here, multiplication code. I'll add another comment here. I'm going to call it what? Division code. So I'm just going to comment here that segregate function definitions. Segregate function definitions, FUNCT. Definitions and main program. So those are the changes that we're making. So I'll commit these changes. You see, I'm committing directly into the testing branch, and I'll just commit these changes. So after committing these changes, you can see now that if I come back to my code base here, while I'm still on this testing branch, you can see that what the testing branch now, for you to create a pull request, the branch that you created must have been updated. That means some things must have changed. There must be a difference between your branch that you created and the previous branch. So when there's a difference, you can see, okay, so the stuff is that you have made some changes. If you are good with the changes that you made, then you want to create a pull request into the other branch and then merge it. So I'm going to compare and pull requests as usual. So all of this that I'm doing here could have been done with our command line, and I'd love to do that, but the issue with the GitHub stuff and then debugging it might just be an issue. So I'll just create a pull request. So once this pull request is opened, automatically I should have an inkling that our part, you see, our jobs are started running. You can see some checks have not been completed yet, blah blah blah, update us. So if I come into this actions tab here, so actions tab is where you see all of your actions running. So you can see that we have an update main.py that is running from the action that we created. Why? Because we opened the pull requests, and you can see that all of our jobs are running in Hello guys. Yeah, sorry for that break in transmission. It was unexpected. We are almost done though, and this should just be the last thing I'm showing, and we cannot disperse from there. So just before I continue, you can just confirm that you can see my screen, and then I just move on, and then we are done. All right, thank you, teams. So where I stopped was me showing you guys the action where the update main.py was running. So if you can remember correctly, then there was a yellow icon, the yellow color showcasing that what the job was still running, but now the job has run successfully. And if I come here, you see a step. You see, this is where we set up the job. You can see this was where I specified that we're going to install the what? Install the Python 3.10 onto our system. So you can see this is a runner Ubuntu, blah, blah, blah. And we installed Python. And then we checked out our code. This is where we installed the PyTest library. So you can see it's all of the process that ran on my laptop when I was installing the PyTest. Everything was run here also. And then the last thing was where we actually ran the PyTest. So you can see that the same output we had on my system collected 4 attempts, test.main.py, 4 tests passed in 0.025 seconds. So with this, we have seen that what that is working. That is working perfectly. And so going to calculator action. So I'm just going to rerun this. I'm going to switch my branch again, testing branch. And I'm going to close this pull request. So this pull request that I've opened previously, I'm going to close it. So if you can remember correctly, you said our workflow is going to run when a pull request is once opened or reopened. So for me to close this pull request, I'm going to close it here. So let me leave that on that for now. So now I'm going to go back to my code base, and okay, I'm on the testing branch. So I'm going to come to main.py now. And if you can remember correctly, the last time what we did was we added just comments to the code. So let's say now the edit I'm making now is an edit that I want to how do I put it? I want to make a change that actually breaks this code. So to do something like that, I have to change one of these. So let's say for the addition function, for example, so instead of x plus y, if I just make, for example, it's because this is a very simple code base. So any change that we make that breaks it is going to be a change that is glaring, but it's just for us to showcase that example. It's just for us to showcase that example. So it's just for us to showcase that example. So I'm just going to come here for this x plus y. I'm just going to divide, sorry. So this is x plus y, and I'm going to divide it by 2. By 2. I want 2 codes to break. So I'm going to say this one x times. Let me just make this one square. You get, so I'm just going to commit these changes into this branch here. So after committing this change, then I'm going to reopen the pull request. So what we're just trying to showcase is that when there's like a lot of people working on code, using GitHub Actions is going to make sure that it allows you know the code that you need to integrate and the code that you don't have to integrate. It allows you know which code is okay and which code is not okay. So if I come back here to our pull request and go back to the one that was closed, the closed pull request here. So I'm not going to come back into this pull request. So this pull request is still working based on that branch. So I could have just as well created another pull request. That's okay. But I want to also showcase the fact that reopening the pull request will also allow the action to run again. So if I just come here and click on reopen pull request, now I should be expecting 2 checks to fail. Why? Because I have made an edit to the code that allows our tests to fail. Because now addition will not give me the expected value, and also multiplication should not give me the expected value. So this is just none. So you can see that our checks are running already. So You see, you have a what? All checks are failed. So if I go into this action file to see the checks that are failed, in this update.main.py. So for that simple request, just because I made an edit to the code that breaks this code, if I click on this PyTest job, on the PyTest job here, and then look for a list of all of the jobs I ran, you can see that all of this ran successfully. But where we ran into our error was here, where we called the PyTest. And you can see that in this PyTest, 1 test failed and 3 passed. So the reason why the third one passed was because we used 1. You know, 1 raised to power 2 is also going to be 1. So that one passed. But for example, you see that this addition now, what I changed was that what I divided the answer by 5. So it is trying to say that it cannot assert that 2.5 is going to be equal to what 5, where 2.5 is the result that was gotten from what the add function. So based on this, we have a what an error. The code has not run. And with this, imagine, so with this now, the person that created the code can automatically see if there's any change that has to be what that has to be made. If I go to my Gmail, and the way PyTest are set up is that they send automatic mail. I'm just trying to see if they send an automatic notification to your mail that a particular test, when the test fails, they send a mail. If the test runs successfully, they don't send the mail. So they send an automatic mail. You can see this a PR run. The test has what? The test has failed. So you can see all jobs are failed. So this is a way that what integrating using actions, you can easily like spot errors very, very quickly, and those errors can be worked on as soon as possible, so that in the long run you won't have a load of errors that you have to fix later. And you know that the aim of DevOps is to always have continuous integration and development and deployment. So if what you are continuously integrating is error free, then you are very sure that by the time you'll be done with all of your processes, there will be no error that you have to fix, because you have placed steps like this that was able to allow you to view errors immediately and work on them ASAP. So with that, we have we have come to the end of today's live session, and I'm very sorry for the disconnection twice, but I hope I've been able to pass the message through. And this is a very, very easy way, and I think this should have helped everyone understand what it is they submitted in the follow-up lab. So I know there's no time. This is 101 already. So if there's any question, does anyone have any question? You can just send it to me on the chat. But if there's no question and everyone is fine with this, then you can all disperse, and we will see again for the next live coding session after the break. Okay, since there's no question, I cannot see anything on the chat group. But if for adventure any question comes again to you, you can just send it to me on Slack and I will respond to it. So I wish all of you a wonderful weekend, and have a wonderful rest of the day. Thank you.